Welcome to Care Coordination and Interoperable Health IT Systems, Principles and Technology of Interoperable Health IT, Lecture D. This unit will cover the following learning objectives. Number 1. Name and define types of interoperability. Number 2. Explain the complexities of semantic harmonization and the benefits of using standards. Number 3. Describe and contrast intra- and inter-organizational interoperability. And number 4. Identify and discuss common types of tools and technologies used to solve health interoperability problems. In this lecture, we will continue in our coverage of healthcare interoperability tools and technologies. You will be able to discuss terminology management systems, HIE software, and other tools and technology, and also be able to identify and discuss the common types of tools and technologies used to solve healthcare interoperability problems. Terminology refers to the terms we use to identify and define concepts. Examples of terms are those for medications, lab tests, allergy terms, hospital locations, race and ethnicity, and others. Some of these really lend themselves to standards, but some are very local to the organization, like hospital locations. If we only had one health information system and never tried to communicate outside of it, we would have defined those terms once and maintained them as needed in the single system. However, we do not have a single information system, not even within one organization. So what you end up with is the need to manage terminology. There are numerous information systems that serve many niche purposes across multiple campuses, and each one of them may decide to manage the terminology themselves. With overlapping terminology locally maintained on each system, there could be a lot of redundant work, lots of room for discrepancies, and quite a bit of mapping. The more systems with local terminology that need to be mapped, the more semantic harmonization is required. As we learned in the first lecture, the complexity of mappings will grow exponentially as you add more systems and terminology variants. Unfortunately, this problem has already occurred in many organizations and is especially severe as we try to map terms across organizations. Early HIEs were especially challenged with determining how to map clinical data together in a useful way for a patient when it was received from multiple organizations that used local terminologies. Imagine trying to trend a patient's lab results across organizations if each organization used their own local lab compendium. Terminology management is about defining these maps, but defining maps is not as easy sometimes. Think about the kinds of mapping you might have to do. You might think a map is a one-to-one map, and sometimes it is. A one-to-one map is the simplest, although it sometimes is hard to find an exact match. There is also a one-to-many map, where you might find that one concept on one system is mapped to multiple concepts on another system. An example would be a radiology exam. The radiology exam is for an X-ray of a foot. One system might say X-ray foot, and the other system might say X-ray left foot, and it also may have a X-ray right foot, so you can do the map. But you are losing some information. Even worse is the many-to-one map. An example would be 3 pharmacy formulary items, which are very discrete and tell you exactly the pill size, dosage, and form. These might only map to one medication, and the doctor does not have a preference whether it is a tablet or a capsule, nor whether it is 250 milligrams or 1500 milligrams. So that could be a many-to-one mapping. And probably the most complicated of all is the hierarchy-to-hierarchy mapping. Imagine mapping laboratory test panels between two systems. One system might have tests A, B, and C in their XYZ panel, while the other system might have an A, B, D in their XYZ panel. When it comes to terminology mapping, you have to figure out if you are dealing with the same thing. It can be very complex. That is why special terminology management systems are so useful. For example, 2 labs will both have glucose serum tests, but they will have differences because they use different equipment and have different reference ranges and other different characteristics. One EHR could have 5 different discharge summary document forms because maybe they were just created at different times or represent the discharge summary for different departments. At a high level, they are still all discharge summaries. How do you map the concepts together at a high level and still keep them separate at a granular level? This is the kind of thing that a terminology management system can provide for you. As a warning, handling terminology becomes harder as your interoperability needs increase. More systems are added all the time, and this increases redundant maintenance of local terminology and increases potential for discrepancies. Additionally, there are more and more reasons to mine and reuse data for research, quality evaluation, patient safety improvement, monitoring, and decision support. We need smarter systems that can provide online context-specific knowledge resources to the clinician. The work required for terminology management grows exponentially unless you have a way to map to standards and manage terminology mappings. What you need is terminology management. A terminology management system can provide this function. You have a terminology server that owns the terms or concepts for a healthcare enterprise, the relationships among the concepts, and the mapping to local and standard terminologies. Systems in the enterprise can access the terminology management system real-time using API calls. The terminology server could also produce files of terminology mappings that could be loaded into systems. The terminology server receives terms from the different systems that own those terms. For example, a laboratory owns the laboratory test compendium, and the EHR owns a compendium of clinical documents. The terminology server would resolve the information and manage it. In this picture, you see a terminology server being queried by the EHR for concepts and relationships. You also see the laboratory system using local terminology for its tests, but the interface engine is querying the terminology server to find the LOINC codes that are needed when a lab test is sent to a commercial lab, because that lab requires LOINC codes. The interface engine calls out to the terminology server to provide the LOINC mapping. There are several vendor terminology management systems available, and some academic medical centers have built their own in-house terminology management systems as well. A terminology management system can relate concepts. All different types of relationships between terms can be established. You can have hierarchies, synonyms, mappings to other local terminologies, mapping to standard terminologies, and mapping across and within standard terminologies. Terminology management systems are also needed to map terms across the local health information exchanges, state-level HIEs, and a nationwide network. Even with standards, terminology management systems are still required even if standard terminology is used to keep track of variances between systems and version issues. Terminologies may have more than one way to represent a concept. A facility may use more than one terminology. For example, it may have different standard terminologies for formulary terms. There are vendors that provide terminology management systems, and there are also open-source terminology management systems. HL7 provides a standard Common Terminology Services API that is often used when communicating between terminology management systems and applications needing terminology mappings. The HL7 API is called Common Terminology Services, or CTS. When selecting a terminology management system vendor, ask if they use a standard API such as HL7 CTS to minimize site-specific rework. Who is actually going to perform this mapping work? What does it take to do this hard work of mapping? One could do manual mapping, and that requires domain expertise, IT expertise, and terminology expertise that is multidisciplinary. If you need to really get people together, you are going to need leadership and facilitation to guide this kind of collaboration. You could have automated mapping that can help you to a certain extent. There are sometimes toolings available, but in the end, some manual work will be needed to confirm mapping and resolve gaps and issues. You will need to maintain and communicate terminology changes. It needs to be stored and mapped with other terminologies and the change that needs to be rolled out to everyone who needs it. That can be automated to an extent. Maybe sometimes it has to be manual, or maybe there are people who are uploading files into local systems. You need processes and staff for successful terminology maintenance. Experts are also needed to help identify terminology forms and opportunities on an ongoing basis and accomplish these opportunities. So let's talk about our final tool in our toolbox, and that is the HIE software. And the reason why we are talking about HIE software at the end is because it is the mega software that combines all of these functionalities. It has an interface engine, an EMPI, and terminology services. An important feature that an HIE provides is record locator services and record repository management. That is, when somebody queries the HIE for information, it can find out who the patient is, and then can retrieve all the records for the patient across the HIE. Most HIE software complies with the IHE PIX PDQ profiles. Also, most HIE software is tested to ensure it complies with the IHE Cross-Enterprise Document Sharing Profile (XDS), which is a protocol for managing record locations and locating records across an HIE community. HIE software needs to include record locator services, interface engine capabilities, EMPI capabilities, and terminology services. All of these functions are necessary to support an HIE. HIE software also often includes aggregate analytics on the HIE patient population. There are numerous vendors' systems available, as well as an open-source HIE software called OpenHIE. For more general information about health information exchanges, please see Unit 8. The Health Information Management Systems Society, or HIMSS, offers Health Information Exchange certification in a program it calls CONCERT. According to HIMSS, an HIE should provide at least the following capabilities. They need to have a patient identity manager, a record locator registry, and a central or federated record repository to know where all these records are. Also, HIEs often connect to other HIEs, and that will be the cross-domain access. This is how we connect one regional HIE to another regional HIE to a state HIE, and then the state HIE to another state HIE, until we have a nationwide exchange. In addition to the 4 major technologies discussed, there are other tools and technology that can help with interoperability implementation. There are open-source solutions available that developers can use. For example, there are numerous open-source APIs available for use in implementing HL7 version 2 and FHIR. There are also free tools available to help build CDA specifications. These include Art Deco, Trifolio, and the Model Developer Tool. There are also testing environments, such as the FHIR test servers, NIST testing tools, Cypress testing tools for clinical quality measures, and IHE testing tools. These are freely available. The source code and tools listed above are useful to vendors and developers creating interoperable products. However, providers can use them to build site-specific implementation guides, validate their implementations, or do custom development internally. The National Institute of Standards and Technology and Cypress develop testing tools to allow vendors and providers to test interoperability functionality for ONC certification of products. However, these tools are helpful for anyone working with interoperability because they provide the ability to submit sample messages or documents and validate if they are formatted correctly. They also provide online help, examples, and easy access to implementation guides. There are other tools and vendor products that could also be used, and new tools are always being developed. Interoperability tools are also called middleware, since they are in the middle between communicating systems. As you can see from this lecture, they provide a very important role. They help to solve the problem of managing the complexities of healthcare interoperability. They help with the management of each unique connection. All interfaces go to and from the middleware. Middleware helps manage the connections and the variance between the systems. Middleware helps manage the differences in the data terminology and the differences in patient identification and provide mappings and linkages so that records can be found across organizations and data can be linked and compared. Middleware helps patient records across disparate systems. Middleware, in conjunction with standards, is what helps us manage interoperability at scale. In a point-to-point model, in addition to needing semantic harmonization between every system, the managing of connections is very decentralized as well. When all of these different systems need to be connected, you need to have every system understand a lot about interoperability, and there is no central management system. With middleware, the connections are more centrally managed in more of a hub-and-spoke type model. It allows for central management of connections and provides a place to adjust for variance in standard interpretations between systems. Of crucial importance is that the data is flowing at all times so that the right information is available at the right place at the right time. Standards and our methods of implementing interoperability are always advancing, but the need for tooling to manage the complexity remains. The other thing that middleware does is give an extra unintended benefit, such as zone of expertise. For each of the tools listed, staff is required to support the software, configure the maps and translations, maintain the quality of the data, and keep them up and running. As a result, a side benefit of these centralized services is specialized zones of expertise. You get the terminology experts, patient matching experts, interface experts, HIE experts, and standard experts. This concludes Lecture D of Principles and Technology of Interoperable Health IT. In this lecture, we completed our coverage of common healthcare interoperability tools and technologies. The major tools and technologies covered included terminology services, Enterprise Master Patient Index, interface engines, and HIE technology. Other tools and technologies, such as APIs and testing tools, were also discussed. Interoperability middleware, such as interface engines, terminology management systems, enterprise master patient indices, and HIE technology are important technologies that help manage the complexity of interoperability implementation and continued support. This concludes Unit 4 of Principles and Technology of Health Interoperability. The summary of this unit is that there are 3 levels of interoperability: foundational, structural, and semantic. Semantic harmonization is difficult but needed to achieve semantic interoperability. Standards are essential for achieving large-scale interoperability. There is interoperability within an organization, i.e. intra-organizational interoperability. And there is interoperability between organizations, i.e. inter-organizational interoperability. There are characteristics of each type. Inter-organizational interoperability is harder. Tools used to assist with interoperability include interface engines, Enterprise Master Patient Indexes, EMPI, terminology management systems, Health Information Exchange HIE software, as well as other tooling such as testing tools from the National Institute of Standards and Technology.